So in this video we're going to do things a little differently. This is just Microsoft Excel that I have open right here. And I've created a spreadsheet to help us learn a little bit more about cost curves and to try and get a bit of an intuition for why they actually look the way that they look. So just so that you know, to start with, I've already worked out how these graphs are going, what they're going to graph. So we're just going to fill in the table, and then we're going to talk about the graphs a little bit, and then in the next video I'll take the graphs and kind of make them a little prettier, copy them over into the Paint program that I'm normally using so that I can draw on them and talk about them a little bit more. But I want you to see where they actually come from, so I wanted to show you this. Alright, so we're going to start down here. And this is just kind of the story to kind of put this in context. So let's say that I'm making surfboards. I've talked about surfboards a lot. I surf, and so it's just kind of a fun thing to talk about for these examples. So I rent a shop just to put all my stuff in where I make surfboards, and I pay $2,000 in rent per month. So right off the bat, we know that my fixed costs are going to be $2,000 a month because rent isn't going to change no matter how many surfboards I make. So I'm just going to put 2,000 in there, and then the wonderful thing about Excel is that I can just take that and drag it all the way down so that we have 2,000 no matter how many workers I hire. And you can see over here that that created a graph for fixed cost, which is just constant no matter how many workers I've hired. On this axis is workers I've hired, and on this axis is dollars in cost. Okay, so then on top of rent, I can hire employees to work for me making surfboards for $1,000 per month, per employee. So each employee I hire is $1,000 per month. And so that's going to be a variable cost because that's going to change depending on how many employees I hire. And so we're going to go ahead, and if I hire 0 employees, this will be equal to $1,000 times 0 workers, which will be $1,000. But the wonderful thing, again, about Excel is that if I just go ahead and drag that all the way down, now we have $1,000, $2,000 for 2 employees, $3,000 for 3 employees, $4,000 for 4 employees, and so on. And now we know from the previous video just about cost curves that total cost is just fixed cost plus variable cost. So let's go ahead and just fill this in as total cost is equal to fixed cost plus variable cost. So if I don't hire anyone, I just pay rent. If I hire one person, I pay $3,000, $2,000 in rent, and $1,000 in their salary. And as we go all the way down, the maximum that I can pay per month for this table is $10,000. So that's all that is going to fill in this graph over here. These are just this is just fixed cost, variable cost, and total cost. And you can see how it plays out that total cost is just variable cost here plus this distance from fixed cost to 0. So we'll do a little bit more with how the cost curves actually stack up graphically in the next video because I can't draw on them here. But I just wanted to point that out. Alright, so, oh, sorry, I need to go ahead and, no, we'll just go ahead and keep on going. Okay. So then average fixed cost, we know from the cost videos also, is just fixed cost divided by the quantity produced. So that's going to give us an error because you can't divide by 0, but Excel goes ahead and puts that at 0. And so if I drag that down, we're going to see that my, you know what, let's not start there. Let's just go ahead and leave that like that. So we're going to see that my average fixed cost declines as I go and produce more and more units. And that's something that we see almost always, is that average fixed cost is, if fixed cost is constant, then average fixed cost will decline as quantity produced increases, just kind of a little fractions. Okay, so average variable cost, then this is just going to be the variable cost divided by the quantity produced. And again, dragging that down, you can see how variable cost behaves as we go forward. And the thing that I want to point out here is that variable cost starts by declining, and then it reaches a minimum somewhere in here, and then it starts to increase. And so that's going to be important coming up in a little bit. So then we have two ways to define average total cost, and I'm going to show you that those are exactly equivalent. We can either make average total cost average variable cost plus average fixed cost, and so I'm going to do that and drag that all the way down. And then I want you to keep your eyes on this graph right here, and I'm going to change how I define it. I'm going to make average total cost equal to total cost divided by the quantity produced. And I want you to see that the graph doesn't change at all, and it doesn't change when I drag it down. So those are two equivalent ways of defining the exact same thing. And then finally, marginal cost per unit, which is sometimes called marginal cost and sometimes called average marginal cost, is just equal to the change in total cost. So I'm going to put these in parentheses first. So E8 minus, this will be E7. So that's the change in total cost divided by the change in quantity produced. And I'm going to put that in parentheses also. So B8 minus B7. Not B7 to C8, just minus B7. There we go. And we'll drag that down, and Excel does this wonderful thing where it keeps that everywhere. It keeps it, the relative positions, constant. And so now we have this blue graph for marginal cost. And the first thing that I want to say about this is that, are we ever going to hire this 8th employee? Let's just go answer that question first. Are we ever going to hire this 8th employee? So if we hire 7 employees, we produce 42 surfboards. And if we hire 8 employees, we only produce 40. That 8th guy is just, there's not enough room in the shop, and he just gets in the way, and everyone gets angry, and we produce less as a whole. And what's more, that my total cost increases from $9,000 to $10,000. So any company that's trying to make money is not going to hire this last guy, because 1, we have to pay him, and 2, he just gets in the way. So I wanted to include this right here so that you can see what happens if you include someone that you have to pay and that also makes you less productive. You get this negative marginal cost here. And so we never have that. That just makes absolutely no sense whatsoever. So I'm just going to delete this entire, I'm going to clear the contents in this entire row so that we just don't have that on our graph. I wanted to talk about it, but I want to be able to talk about the graph without that kind of funky point in there. Okay, so the two major things that I want to point out in this video are, first, that when marginal cost is below average variable cost is decreasing. And when marginal cost is below average total cost is decreasing. And here's the reason why. Marginal cost is the cost of producing that next additional unit. So if that cost of producing the next additional unit is lower than the cost that you're paying for the previous unit, of course when you produce that next unit, the average is going to drop down. So I'll say that one more time because it's a little confusing. Marginal cost is the cost of producing the next additional unit. So if the next additional unit is cheaper to produce than the last unit you produced, of course, once you produce that cheaper unit, average cost is going to drop. And that's true for both average variable cost and average total cost. And the reason it's not true for average fixed cost is that average fixed cost is just dependent on the fixed cost here. It doesn't factor in the variable costs at all. So we're not taking into account both of them, we're just taking into account this fixed cost here, which is always going to decline because quantity produced is increasing. Alright, the next thing that I want to point out, and I don't want to go into an in-depth explanation here because it's kind of complicated and it requires a bit of calculus, but marginal cost intersects average total cost and average variable cost at their minimums. So we can see marginal cost intersects average variable cost right here at 30. So at 30 units of production, this line right here, I'm saying that average variable cost is going to be a minimum. And if we look up and down here, it is a minimum. And I'm just going to leave it at that. Just remember that marginal cost intersects average variable cost at its minimum. Now it also intersects average total cost at its minimum. And so marginal cost intersects average total cost somewhere in between 36 and 40. So it looks at about 38, maybe a little bit more. I'm going to guess 38 units of production. Maybe, I don't know. 38 sounds about right. Maybe a little bit less, maybe 37. So we don't have that point on our chart right here, but the point 36 is the closest one to it, and we can see that that's the lowest value that we have for average total cost also. So probably 37 or 38 will be the actual minimum, but this is close enough for our purposes. And just also, again, marginal cost intersects average total cost at its minimum. So that's all that I want to say about cost curves here. I'll do a couple more examples and some more like applied work in a couple other videos where I can actually draw on these curves, and I'll see you there.